Welcome to today's Explainer. Our beautiful planet Earth has just one moon, right? It controls our oceans, it lights up our night sky. But what if things were completely different up there? Get ready, because we're about to explore a giant cosmic what if that is absolutely going to blow your mind. What if Earth had two moons?
Okay, I want you to imagine something truly extraordinary. Pretend you're standing out in your dark backyard tonight. The crickets are chirping, you look up at the sky, expecting to see our normal, lonely moon. But wait, what if right next to it there was a second, glowing, beautiful lunar disk? Two huge moons side by side, just shining down on you. Depending on how far away they were, they might be right next to each other, or maybe on totally different sides of the sky. I know, it sounds like absolute magic, but scientists actually think about what this would do to our world.
First off, measuring time would suddenly get totally wacky. For thousands of years, humans have used the moon's phases to organize our calendars. That's literally where the word months comes from. But if we had two moons, we'd have two completely different overlapping monthly cycles. Imagine trying to figure out if it's a full moon, and your friend goes, which one? Moon A or Moon B? It would be so confusing. We would have to invent completely new holidays and traditions just to keep track of these two giant glowing rocks in the sky. All right, let's leave the backyard for a second. Let's take our adventure to a sunny, beautiful beach. We really need to see how the oceans would act with two moons up there. Have you ever built a sandcastle and watched the water slowly creep up and wash it away? That happens because of tides. And believe it or not, the ocean's tides are actually controlled by the moon. Let's break down exactly how that works into three really simple steps. Step 1, the Earth spins around and around. Step 2, as we spin, the moon's gravity pulls on the ocean water, making this big bump in the water called a tidal bulge. And step 3, wacky wild waves. NASA explains that as our planet turns, different beaches move right through that big bump of water, making the tide go high and low. But with two moons, oh boy, we would have two totally different poles happening at the exact same time. And that actually brings us to a really important quote from scientists. They say, there is no single answer such as the tides would simply become twice as high. See, it's a huge tug of war. Sometimes the two moons would line up perfectly and pull together, creating these gigantic, wild waves. But other times, they might be on opposite sides of the Earth, pulling against each other, which can make the waves super tiny and weak. Basically, our oceans would turn into a very, very complicated water park. Now, let's leave the noisy beach and tiptoe quietly into a dark, nighttime forest. Shh, you hear the owls? In our world today, the forest gets pretty dark at night, but with a second huge moon shining down, everything changes. The forest would be completely illuminated by the bright glow of two big moons, acting almost like a giant natural nightlight. With a second moon, the amount of natural light flooding the Earth would be massive. We are talking double the moonlight. If the new moon was the same size and brightness as our current one, nighttime wouldn't be spooky and dark anymore. It'd be bright enough to see your own shadow in the middle of the night. It would honestly look almost like early morning. So how would the animals feel about this giant nightlight? Well, at first, a whole lot of confusion. Many animals, like frogs, moths, and those owls we heard, they use the dark moonlight as a cue for when to hunt, move around, and even navigate. With double the brightness, their schedules would be completely messed up. But nature is amazing. Over millions of years, these animals would slowly evolve. They would adapt to this bright new world through natural selection, changing how they live just to match the two moons. Okay, now let's look at the big picture. Put on your space helmets because we are blasting off into outer space. 3, 2, 1, lift off. We're zooming way, way out into the stars to look back at our entire Earth from above. Seeing our planet from space with two moons orbiting around it would look dramatically different. And we really need to learn how they actually stay up there. To understand how they stay up there, we need to learn a magic science word: gravity. Gravity is the invisible pull that objects have on each other. It's kind of like giant invisible strings connecting planets and moons so they don't just float away into space. It is the exact same force that pulls the oceans to make the tides, and it's what makes the moon swing around the Earth in this beautiful, endless, giant space dance. And wow, what a complicated dance it would be. Instead of just the Earth and our single moon dancing together with the sun, we now have four massive partners on the dance floor: the Earth, the Sun, moon number 1 and moon number 2. All 4 of these giant space rocks would be pulling on each other with those invisible gravity strings. Every single time they moved, they'd tug on the Earth and they would even tug on each other. So here's the really crazy part. All this pulling actually tires the Earth out. Did you know our current moon's gravity is actually slowing down the Earth's spin right now? It's true. Over super long periods of time, this gravitational energy transfer acts kind of like brakes on a car. If we added an extra moon, the combined pull could slow down the Earth's rotation even more. Over a really, really long time, our 24-hour days could stretch out and become even longer. And with exactly 2 moons, we'd have double the chance for something completely spectacular: solar eclipses. An eclipse is when a moon blocks the sun's light and casts a giant shadow on Earth. With 2 moons, the sky would have this crazy, complicated pattern of shadows. We could even have overlapping eclipses, casting magical double shadows all over the planet. The rhythms of the sky would be completely transformed. But wait, does it matter how big the new moon is? Ask yourself, what if the second moon was just a tiny space rock, like a cosmic marble? Or what if it was huge, like a giant planetary beach ball? Does the size change how the dance works? You bet it does. The whole scientific thought experiment tells us there's no single 2-moon answer, because size is the most important variable of all. Let's compare them. Scenario A is a tiny moon. If the second moon was super small, its invisible gravity pull would be really weak. It might just be a pretty little speck of light in the sky, causing very modest changes. But scenario B, a huge moon? If it was the exact same size as our regular moon, its gravity would be so strong that we'd have those wild, complicated tides and a completely chaotic space dance that strongly messes with the Earth's spin. Now, if you're feeling a little dizzy thinking about this wild space dance, don't worry. I want to comfort you by letting you know that having multiple moons is actually totally normal in space. Earth is kind of the weird one for only having one. Other planets in our solar system have huge families of moons dancing around them all the time. For example, let's just look at our red neighbor right next door, Mars. Mars already has 2 little moons perfectly dancing around it. Their names are Phobos and Deimos. Now, they're pretty small, honestly more like space potatoes than giant glowing orbs, but it proves that a planet can easily juggle 2 moons at the same time without dropping them. But what if the giant space dance goes wrong? Uh-oh, could they crash? Well, if we had 2 huge moons around Earth, they would be pulling on each other constantly. If their orbits brought them too close together, their gravity could actually disturb their paths. They'd get incredibly wobbly. Scientists call this orbital instability, and it definitely brings a little bit of dramatic suspense to our story. If things get wobbly, there are 3 main endings to this space dance. Ending 1, they find a perfect mathematical arrangement and stay perfectly safe for billions of years. Ending 2, the invisible strings get tangled and one moon gets slingshotted right out of Earth's orbit and flies away deep into dark space forever. Or ending 3, they collide. They bump right into each other in a giant cosmic crash. Scientists actually use giant supercomputers just to figure out how to stop that from happening. So, what does this all mean for us? The science summary says it perfectly. We would be living in a different gravitational system. Earth would absolutely still be our beautiful home. You'd still go to school, you'd still play with your friends, but the deep blue oceans, the starry skies, our months and calendars, and all those nocturnal animals in the forest, they would live by completely different magical rules of gravity. Which leaves us with one final, incredible thought to wonder about. Tonight, when you look at your window at our one beautiful, quiet moon, I want you to imagine the billions of years of giant space dances happening all over the universe. And ask yourself, what kind of perfect mathematical arrangement would it take for 2 large moons to actually survive in a space dance together around our Earth? It is a wonderful mystery. Keep looking up, keep asking questions, and thanks so much for joining me today.